Welcome to the fifth and final part of this video series. I explain and show you how you can achieve a smoother running motor. When running the simple application, you can see that the motor is running very loudly and unstable. To solve those issues, we have to add a few steps in our applications. I have prepared those applications already and I will explain what we changed or added to improve the applications. We will start with the application of the STG700. First, we implemented micro steps on the stepper motor block, meaning 1/8 steps. That makes the motor a little more quiet. The program string down right are the two LEDs. The green LED will be on while the motor rotates clockwise, meaning right. And the red LED will be on while the motor rotates counterclockwise, meaning left. The calculation in the macro block, get direction rotation, is basically a comparison of the actual value and the set point. As I have already mentioned in the third video, macro blocks contain subfunctions and they help to keep the worksheet clear, and you can also reuse them if necessary. The switch we implemented will enable or disable to update the new position to the stepper motor. Now I will show you what we have modified on the application of the STG570. The upper program string shows that we now calculate with angles instead of amounts of steps. There is a subtraction by 5, meaning the motor will make steps between approximately 5 and 20 volts input. The result is divided by 15 and multiplied by 360, which transforms the voltage input into angles of steps. The limiter of that calculation just says that the ratio 0 to 360 degrees, and no negative values can be transferred further from this point. Now, to achieve a more stable value for that calculation process, we implemented a macro block called moving average. With that average, we clear out the jittering of the input value a little bit. Unfortunately, there was still some fluctuation. So next we calculated a hysteresis in the macro block, moving hysteresis, which is right before the can send function block. The moving hysteresis defines a threshold value, and only if this value is overstepped, new data will be released. Now the noise does not influence the motor anymore and it runs more quietly. To be able to turn on and turn off the motor, we implemented a comparator function block and the switch. So the motor will turn on if the input is 1 volt or higher, and it will turn off if it's below 1 volt. Let's have a look at the result of our changes in the applications. You can see and hear that the motor is running smoothly and quietly now. I hope I could explain all the steps of the example application. You might have already found a solution that is differing from this example solution, but as you know, there isn't just one way of doing it. So find your own style of programming. And if there are still some questions or remarks about this example or your own, have a look at the forum on www.micon-L.de. Ask your questions and get in touch with other users.